this section, we'll be looking at number 8, internal walls. Internal walls can be solid, typically constructed from brick or blockwork, or can be a framed construction. Framed partition walls are sometimes referred to as stud walls and can be constructed from a timber, steel or aluminium frames clad with boarding such as plasterboard, timber, metal or fireboard. Partition walls can also be glazed. They may be purpose designed and constructed or may be a modular system and can incorporate openings, windows, doors, ducting, pipework, sockets, wiring, skirting, architraves, etc. Frame constructions may include insulation to prevent the passage of sound or fire between adjacent spaces. It is also important, therefore, that at the top and bottom of the wall are properly sealed against the floor and the ceiling, and where a raised floor or suspended ceiling is present, it is important to consider the potential of flanking through the voids above and below. As they are non-load bearing, internal walls can provide good flexibility, particularly if they are lightweight frame systems, as wall positions can be changed relatively easily and inexpensively without impacting on the overall structure of the building. You can see all the numerous types of internal walls in the images. The specification of partition walls will depend on the requirements for weight, cost, speed of installation, availability of materials, longevity, durability, flexibility, ease of configuration, and sound and fire insulation and surface finish. They may also be required to perform a secondary structural role, for example, supporting cupboards or shelving. Pattressing is common to address this and makes the wall more durable to fixings. A pattress is a plywood or timber board fixed within a partition to which equipment can be secured, such as ceiling roses, power outlets, basins, wall cabinets, etc. Internal walls or partitions are non-load bearing that separate spaces in buildings. As well as spatial and physical division, and behind simple surfaces lie assemblies of materials combined to meet specific performance requirements and function relating. Let's have a look at some of these requirements and functions. You've got spatial and physical separation, structural strength, fire resistance, durable enough to withstand wear and tear for which the building was designed for, as you can see in image 1. Robust enough to receive fixings, as you can see in image 2. Acoustical insulation, privacy, pleasing in appearance and in character with the rest of the building, as you can see in image 3. Flexibility of layout, as you can see in image 4. And of course, loading or non-load bearing. Okay, let's move on. There are 4 types of interior walls. Number 1, you've got firewalls. Number 2, you've got fire compartment walls. 3, you've got shaft walls. And 4, you've got other non-load bearing partitions. So number 1, firewalls, as you can see from the image 1. This is a wall that forms a separation to restrict the spread of fire through a building. It extends continuously from ground to roof. Firewalls are used to divide a building into smaller units, each of which may be considered as a separate building when calculating allowable heights and areas under a building code. A firewall must either meet a non-combustible roof or extend through above the roof by a specified minimum distance. Openings in firewalls are restricted in size and must be closed with fire doors and wired glass. Number 2, we've got fire compartment walls, and you can see this in image 2. These walls also form a separation to restrict the spread of fire through a building, but they do not extend from foundation to roof. They are used to divide a building between mixed occupants, for example a kitchen and an office area, and for the enclosure of stairways and exit corridors. Openings in fire separating walls are also restricted in size and must be closed with fire doors and wired glass. Number 3, we've got shaft walls, and you can see this in image 3. These are used to enclose multi-story open space in a building, such as an elevator shaft, a shaft for ductwork, conduits or pipes. The walls should provide the fire resistance called for in the building regulations. Lift shaft walls should be able to withstand the air pressure and suction loads placed on them by the movement of lift cars. Lift shafts should also be designed to prevent the noise of elevatory machinery from reaching other areas of the building. 4, we've got other non-load bearing partitions. And these are the other partition walls in a building that are not required as fire separation or to take a structural load. All right, let's have a look at what materials are used for the 4 types of interior walls. So generally, load-bearing partitions will be made from concrete blockwork, and you can see this in image 1. Fire compartment walls can be made from in-situ concrete, bricks or blocks. Shaft walls will be made from in-situ concrete, blocks or occasional plasterboard. Non-load bearing partitions can be constructed from a range of materials, including glass, plastics, steel or wood studs. Partitions may be framed with steel or wood studs and faced with gypsum boards. Okay, let's now focus on the timber stud walls and the mason wall to conclude this section on internal walls. Firstly, the timber stud wall, as you can see from image 2. Stud partitions are still extensively used for internal walls of domestic buildings. These are non-load bearing internal dividing walls which are easy to construct, lightweight, adaptable, and can be clad and filled with various materials to give different finishes and properties. These lightweight stud partitions are used throughout in timber framing builds as well as in traditional builds. For load-bearing situations, they can be strengthened with plywood or orientated strand boards, known as OSB, sheathing before plasterboarding to stiffen the structure. These lightweight stud partitions are used throughout in timber frame builds as well as in traditional builds. For load-bearing situations, they can be strengthened with plywood or orientated strand board sheathing before plasterboarding to stiffen the structure. This is commonly known as OSB boards. Room partitions on upper floors are best built in timber studwork. It isn't wise to build blockwork partitions on timber joists because, apart from the extra deadweight, which is about twice that of stud partitions, they are likely to crack when the joists dry and shrink back. General construction consists of 100 x 50 mm or 100 x 75 mm sole plates and head plates, as you can see in images 3 and 4. Vertical members or studs made from 100 x 38 mm or 100 x 50 mm membranes are nailed in between at 400 mm centers. The spacing is to suit the plasterboard or other cladding material. Nogging or bridging pieces are inserted between the studs to stiffen the partition, and the timber frame is then covered with plasterboard on both sides and finished with a 3 to 5 mm coat of plaster. Secondly, we have mason walls, as you can see in image 5. Mason walls are constructed to create partitions made up of blocks and bricks. As the external structure rises, it will need to be buttressed by the internal wall or in a leaf. On the ground floor, those walls will be supporting the first floor structure too. Because of this, they should rise from the foundations as load-bearing walls and be tied into the external structure as it is built. Lightweight or medium density blocks, normally 100 mm thick, are commonly used at this stage and can be used for the ground floor partitions as well as long as they are the same density. Choosing different densities can result in differential movement between the two. And for improved appearance, partition walls may be faced with ceramic tiles.